Welcome to the Deep Dive, where we try to make sense of the latest in AI research. If you're working in AI or ML, you know keeping up is, well, intense.
It really is. Almost overwhelming sometimes.
Right. And these deep research tools, they promise help, but often feel rigid. Today we're looking at an NVIDIA paper that might just shake things up. It's called Universal Deep Research. Okay, so for the super quick version, the 1-minute summary, we're talking NVIDIA's Universal Deep Research, or UDR.
Yeah, and the big problem it solves is how inflexible current research agents are. They usually have, one way of working, one strategy baked in, and you're stuck with whatever language model they picked.
But UDR, totally different approach. It's a generalist agent, meaning it can plan and act, but, and this is the key part, it lets you write your own research plan in just plain English.
Exactly. It turns that plan into code. And here's the kicker. You can use pretty much any language model you want with it. No retraining needed.
Wow, okay.
So you get way more control. It's more efficient because the main logic runs as code, not expensive LLM calls all the time. And it's safer because it runs in a sandbox. It's really about giving technical folks the power to build custom, trustworthy research tools.
Okay, that definitely sounds like something worth digging into. Let's unpack this UDR paper, see how it works, what the benefits are, and what it could mean for researchers like you listening. So, before we get fully into UDR, maybe let's set the scene a bit. What are these deep research tools, or DRTs, that already exist? What's the general picture?
Sure. So DRTs are basically AI assistants designed for, deep research. You give them a prompt, maybe a complex question, and they go off, search loads of information, and come back with a structured report.
Yeah.
Much more involved than just a chatbot.
Right, more than just a quick answer.
Exactly. In the sort of general public space, you've got tools like Gemini, Perplexity, OpenAI's deep research. They often work by planning research steps, browsing the web iteratively, finding stuff or finding searches, and repeating until they have enough info.
Okay, makes sense. Iterative browsing.
Yeah. And then there's Grok 3 Deep Search, which is interesting. It has this two-tier system. Bots constantly indexing the web in the background, and then an on-demand agent does targeted searches for your query, generates subqueries, fetches pages live. It uses chain-of-thought reasoning to process it all, check sources, even cross-verify claims.
Okay, so that covers the web-focused ones. But what about inside companies? Enterprise DRTs must be different if they're dealing with internal documents. Right?
Oh, absolutely.
Yeah.
Enterprise needs are often much more specific, working with internal databases. NVIDIA's own AIQ research assistant, for instance, uses a strict 5-step process. Plan, search, write, reflect on gaps, then list sources. Very structured.
Okay.
Salmonova Deep Research is similar, also 5 steps, document-focused. It parses the prompt, outlines the document, uses web tools, but then it can delegate tasks to specialized agents, like, say, a financial agent, for certain analyses before synthesizing everything into a report.
Specialized agents, interesting.
And maybe the most different is ERP AI Deep Research. It doesn't really use documents in the same way. It uses a graph-based AI architecture. It sees enterprise data as knowledge graphs, uses graph neural networks to access them, and aggregates info across the graph. Totally different paradigm.
Wow, okay, so lots of different approaches. These tools sound powerful, but the UDR paper really highlights some key frustrations. The problem statement they lay out, it felt pretty spot on.
Yeah, they really nail 3 core problems. P1, the first one, is about restricted user control. You often can't easily tell the tool, only use these specific journals, or make sure you cross-check against this trusted database, or even just manage how much searching it does, which affects cost.
Right, you can't easily enforce those specific constraints, and that gap between what you want and what the tool does seems like a big deal, especially for enterprise use cases.
Exactly. Imagine drug discovery or legal research. You need that control over sources and validation, which leads straight into P2. The lack of specialization. Current tools often can't handle the really specific, nuanced research strategies needed in fields like finance, legal, healthcare. You end up needing expensive, custom-built solutions, which kind of defeats the purpose of an off-the-shelf tool.
You're forced into a generic workflow when you need something highly tailored. I can see how that's a problem. And the third one, that felt very relevant given how fast AI models are changing.
Definitely. P3 is about fixed models. Most DRTs are welded to one specific language model, or maybe a family of models. You can't just say, hey, this new amazing model just dropped, let's plug that in. You're stuck.
Which means you can't take advantage of the latest breakthroughs easily. You're locked into whatever the vendor chose maybe months or years ago.
Precisely. It limits your flexibility, your ability to use the best tool for your job right now.
So putting it all together, if you want truly customized, cutting-edge research, Current DRTs often leave you wanting more control, more specialization, and more model choice. It feels like a one-size-fits-all approach that doesn't quite fit anyone perfectly.
That's a good way to put it. These problems really limit how useful and impactful these tools can be in practice for technical users.
Okay, so that sets the stage perfectly for UDR. We see the limitations, the frustrations. How does Universal Deep Research propose to fix this? How does it deliver on that bring your own model and strategy promise?
Right, so UDR is presented as this generalist agentic system built specifically to solve those three problems. The absolute core idea, the main contribution, is enabling users, technical users, to create, edit, and refine their own custom research strategies.
And they do this without needing to retrain or fine-tune the underlying AI model.
Exactly. No fine-tuning needed for the strategy part. And crucially, it's designed to work with any language model you want to plug into it.
So that bring your own model and strategy tagline isn't just marketing fluff, it's literally what it does. That sounds incredibly empowering for researchers. We can finally define how the research gets done, not just what topic to research.
It really is transformative for technical users. The key mechanism is UDR's ability to take your research strategy, describe in natural language like a list of steps, and convert it into executable code.
Into actual code?
Yes, actual code snippets. This gives you total control over the whole process. Validation steps, data sources, report structure, everything.
And who are they aiming this prototype at? Is it meant for the general public?
Not primarily, no. The paper explicitly states it's aimed at developers building agentic systems in industry and also AI researchers who are exploring how these agent systems work. It's for people comfortable defining workflows and potentially looking at the generated code.
Got it. So for the builders and the tinkerers among us, okay, let's get into the weeds then. How does UDR actually do this? What are the inputs and what happens in those two big phases, strategy processing and strategy execution?
Okay, so inputs first. UDR needs two main things from the user. First, the research strategy. This is your plan, basically. A list of steps, usually bullet points or numbered, telling the UDR instance exactly how to behave.
My recipe for the research.
Pretty much. And second, the research prompt. This is more like what you give other DRTs, the topic, the specific question, maybe requirements about the content or format of the final report. The strategy you provide is responsible for pulling the necessary details out of this prompt.
Okay, strategy and prompt. And then it kicks off phase one, strategy processing. What happens there?
This is where the magic starts. Strategy processing takes your natural language strategy and turns it into Python code. It uses a language model to do this translation, but, and this is important, with very strict guardrails.
Guardrails.
Yeah, it limits the kinds of functions the generated code can call and the code structures it's allowed to use. Safety first. The output is a single Python function that takes the prompt as input and yields notifications as it runs.
Yields notifications, like status updates.
Exactly. And another key detail, they found it was crucial to prompt the LLM to generate the code step by step, mapping each code block explicitly back to a step in your original strategy. This stops the LLM from, getting creative and skipping steps or combining things in ways you didn't intend.
Keeping the LLM honest to the user's plan. That's clever. Okay, so phase one gives us this executable Python function. Then phase two, strategy execution.
Right. In phase two, that generated code is actually run, but inside an isolated sandbox. Think of it like a secure container.
Okay, safety again.
Definitely. And there are some really neat operational details here. First, how it handles state. Instead of trying to cram everything into an ever-growing LLM context window, which gets expensive and hits limits fast.
Yeah, the classic context window problem.
Right, UDR avoids that. It stores all the intermediate results, findings, variables, whatever, as named variables within the Python code's execution state. This means it can handle really complex, long-running research tasks using a surprisingly small context window for the LLM itself. They mention around 8K tokens in their tests.
That is huge. Storing state in the execution environment, not the LLM context, that's a game changer for efficiency and complexity.
It really is. Then there's tool use. Any tools like a web search function, maybe an internal database API, are just called the standard functions within the generated Python code. Because the state is managed outside the LLM, the code can reliably access info found in earlier steps. No forgetting.
Okay, reliable tool calls. And how does the LLM fit in during execution?
This is maybe the most interesting part, LM reasoning. The language model isn't the master controller running the whole show. Instead, the generated code is the orchestrator. The LLM is treated like a callable utility.
A utility.
Yeah, the code calls the LLM for specific, localized tasks when needed, Things like summarize this chunk of text, or rank these findings, or extract entities from this document. The LLM does the smart language stuff on demand, but the overall flow, the logic, the steps, that's all driven by the user-defined strategy embodied in the code.
Wow. So the LLM is a powerful tool used by the strategy, not the thing defining the strategy on the fly. That flips the common agent model quite a bit.
It really does. And finally, those notifications we mentioned. They're also explicitly defined by the person writing the strategy. You use yield statements in the Python code, or specify notification points in your natural language strategy to send progress updates back to the user interface. Real-time, structured feedback.
That focus on code for orchestration and treating the LLM as a specialized tool, it feels like that design would have major upsides: reliability, efficiency, security.
Absolutely. On reliability, they found that generating the whole strategy into one coherent piece of code up front was much more robust than approaches that make step-by-step decisions using an LLM at each stage. Fewer ways for it to fail, like skipping steps or misunderstanding instructions mid-flow. Plus, the generated code is human-readable. You can actually look at it and audit what the agent is going to do.
Transparency, nice. And efficiency.
Big win there. Running the orchestration logic as compiled Python code on a CPU is way cheaper and faster than constantly prompting a massive LLM on a GPU for every little decision. You only use the expensive LLM for the tasks that genuinely need its language power, on smaller text snippets, lower latency, lower cost.
Makes perfect sense. And security. You mentioned the Sandbox.
Crucial point. Since you're running code based on user input, you have to think about security. UDR is designed from the ground up to run that generated code in a restricted sandbox environment, like using libraries such as Piston. This prevents the code from accessing the host system, messing with files, or having other side effects. It's a non-negotiable for deployment.
Right. You don't want your research agent deciding to reformat your hard drive. Okay, so the end result is real-time updates while it's working, and then a final comprehensive report. Sounds incredibly useful for anyone needing that control and transparency.
Exactly. It's about making the process auditable and predictable based on your rules.
The paper doesn't just talk theory, it shows examples. It gives sample strategies and even describes a UI. What can we learn from those?
Yeah, the examples really help illustrate the flexibility. They show 3 conceptual strategies. First, a minimal research strategy, super simple. Get prompt, generate search terms, search, dump results into one big context, write report. Quick and dirty.
Okay, the basic version.
Then, an expansive research strategy. This one's broader. Get prompt, generate topics related to the prompt. Then for each topic, generate search terms, search, gather context per topic, then synthesize a report covering all topics. So more structured hierarchical search.
Right, breaking down a big topic. And the third one, intensive, sounds like it goes even deeper.
It does. The intensive research strategy is iterative. It starts with some search terms, searches into a temporary context, the subcontext, then uses that context to generate new, more refined search terms for the next round. It keeps iterating, digging deeper, accumulating the best results into a main super context.
Ah, so it adapts its search based on what it finds, like following breadcrumbs.
Exactly. It allows for this adaptive, multi-round investigation. Really powerful for complex questions where the path isn't clear up front. These examples show you can essentially program different research methodologies just using natural language.
That is seriously compelling. Just describe how you want it to think. And the UI they describe makes this concrete.
Yeah, the demo UI sketch sounds pretty straightforward. A search bar for the main prompt, obviously. A strategy selection list so you can save and reuse strategies. An edit strategy button that opens up a text area where you literally type or paste your natural language strategy.
So you can just tweak it right there?
Yep. Then you'd see progress notifications popping up, buttons to stop or generate report, and finally a report viewer to see the output, likely in Markdown.
And they showed outputs too, right? Like the swallow velocity.
Slight chuckle.
Yeah.
They included fun examples like the airspeed velocity of an unladen swallow, alongside more serious ones like US stock movements. It shows the system can handle diverse queries and produce structured reports that actually follow the logic laid out in the chosen strategy.
Okay, UDR sounds incredibly promising, offering a level of control we haven't really seen before. But like any new system, especially in research, it must have limitations, right? What caveats do the authors themselves point out?
They're quite upfront about the limitations, which is good science. They highlight 3 main ones. First, it heavily relies on the language model's code generation ability.
Meaning
The quality and faithfulness of the agent's behavior depend entirely on how well the LLM translates your natural language strategy into correct functional code. While they use careful prompting to minimize errors, Things like semantic drift, where the code doesn't quite capture your intent, or even hallucinated logic can still happen. If your strategy is vague, the code might be buggy.
So garbage in, garbage out still applies, potentially at the code generation level. Debugging might involve checking the generated code itself.
Potentially, yes. The second limitation is related. Trust in user-defined strategies. UDR basically trusts that the strategy you provide is logically sound and will actually achieve the research goal effectively. It doesn't do deep checks on the quality or coherence of your workflow logic.
So if I write a terrible strategy,
You'll get terrible results, or maybe no results. The system executes what you tell it to. It doesn't critique your research methodology.
fair enough. Responsibility lies with the user, which makes sense for the target audience. And the third, limitation.
Limited real-time interactivity. Right now, while you get progress updates, you can't really jump in mid-execution and tweak the strategy or redirect the agent based on intermediate findings other than hitting stop. All the decision logic needs to be defined upfront in the strategy itself.
So no dynamic, oh wait, based on that finding, go look over here instead, kind of intervention during the run.
Not in the current implementation described. It's more fire and forget based on the initial strategy.
Okay, those seem like clear areas for future work. Does the paper offer suggestions on where systems like UDR should go next?
Yes, they give 3 clear recommendations. R1 is about creating a strategy library. For broader use, especially beyond developers, they suggest providing a library of pre-built, effective research strategies that users can pick from and maybe modify instead of always starting from a blank slate.
Where's the barrier to entry? Makes sense.
R2 is control over LM reasoning. They think more research is needed on how to give users finer-grained control over the LLM's internal thinking process when it's performing those utility tasks like summarization or ranking, guiding how it reasons, not just what it reasons about.
Interesting, getting deeper into influencing the AI's process.
And R3 is automated agent creation. They propose looking into ways to automatically generate these kinds of controlled, strategy-driven agents directly from analyzing large numbers of user prompts or desired outcomes, moving towards more automated construction of complex, reliable agents.
Wow. Okay, what an absolutely fascinating look at universal deep research. It really does feel like a significant step forward, tackling those core frustrations many of us have felt with existing tools, giving users that power to define the strategy and choose the model. That's big.
It really is. For anyone working in AI research or ML engineering, the ability to define custom research workflows in natural language combined with model flexibility is incredibly appealing. It points towards research agents that are more transparent, easier to audit, and potentially much more efficient and tailored to specific needs.
It fundamentally changes the relationship, doesn't it? From just giving the AI a goal to actually collaborating on the process by defining the strategy. It pushes the boundaries of user control over AI reasoning.
Absolutely. And that leads to a really interesting question for you, the listener, to think about. As these AI agents get smarter and more capable, how much control do we actually want over their internal processes, their thinking? What's the right balance? And can you imagine a future where crafting these custom auditable research agents is as common for technical work as using spreadsheets is today? Definitely something to mull over.